Good afternoon, everyone. My name is Khalid, and today I will be walking you through our project, a project we are very passionate about. But before we dive into the technical details, let's start with a quick scenario. Okay, so imagine you are a film director working on a high budget movie. It's time to shoot this crucial 10-minute single shot scene. For a breathtaking view, you decided to go with a aerial view. So you decide to use a drone. It's a trend, right? So you are using a drone, you are flying it, you're taking the scene, and everything is perfect. The actors are nailing the rules today. The camera is rolling smoothly, and with just 2 minutes left, you're confident it's in the bag. But then suddenly, the drone falls from the sky. A battery failure. In seconds, your shot is ruined. The drone is gone. So is your time, and your production budget takes a hit. So this might seems like a small casualty, right? Just some money, some time. Uh, it's okay, we can handle it. But let's raise the stakes. What if this happened during a power line inspection or while monitoring a vast farm in a remote area? We're not talking about money and time now. We're talking about safety risk. We're talking about we're talking about actual casualties that can potentially even be human lives. Okay. And so what is the problem? The problem is, yes, drones are transforming industries. We are advancing different activities, but they are still vulnerable to unpredictable failures. For example, hardware malfunctions or environmental factors. Something like a dying battery or a burnt out motor can cause total loss of control. Even the weather can, even the best drones can be affected by the weather. So, of course, there is solutions. We're not the first one to think about this, right? It's already out there. So, what are the solutions out there? We have the obstacle avoidance, which is great for preventing collision. But if the issue is the drone itself, then what to do? We have geoforcing or restricted areas, and yeah, we not allowed to go to this area, but this doesn't help much. And finally, we have the return to home, which is yes, it's very useful, but not in all conditions. So, so yes, these solutions are helpful, but they fail short in some aspect, one or another. And that's why we are here today. That's why where our solution comes. Our drone health monitoring and emergency response system. It gives you a real-time sensor monitoring as well as a multi-layer emergency response. So what am I talking about? I'm talking about a drone that collects the data of its motors, of its battery, the altitude, the speed is all read from the drone in real time, and it's reflected in your dashboard. Not only this, but it also have a ability to have some multi-layered response system. So if something bad happens, then we have a response mechanism. We have multi-layered response mechanism depending on the issue you have. So if it's a small issue, then we can just warn the user of the drone. If it's a critical issue or if it's a moderate issue, then we can ask the return to home. We can use the return to home mechanism or policy to bring back the drone to its launch place. And finally, if it's a critical issue that cannot really be solved with any of the previous solutions, then we can launch a parachute to minimize the damages happening to the drone. Okay, so as I was saying, we have our dashboard where you can actually see what's happening to the drone. You can see the battery, you can see the drone itself, the attitude of the drone. All of this is shown to you in real time. So you are sensing the drone from your place down on the ground. Not only this, we also integrated our weather APIs. So before you even launch, you can check the weather. You can have understanding of how the weather will be. So before you launch the drone, you can first check the weather. During the flight, also the weather is updated. So not only this, we have for our parachute system, we have an AI model that can detect the safety landing space. So it can tell you which place is safe to land. This place maybe is some grass or some. It's usually like grass, so it's not water, it's not roads, it's not vehicles. All of this is detected, segmented, and the safety place is detected. So what are we achieving here? What's the goal of our project? We are offering you a more reliable operation, no more guesswork, drones you can trust for critical missions. We are saving your money, an asset. We are protecting it for you. Every crash prevented saves thousands in hardware and data and downtime as well. It's not only about money, it's about time as well. We are saving you all of this. Finally, we are ensuring a safe sky and regulation compliance. We are ensuring that there is no, we are reducing the amount of hardware wasted in our using the drones or caused by the drone crashes. So yes, we are not only benefiting, we are benefiting you mainly, we are benefiting the environment by reducing the waste, and we are aiming for a better future. So final thoughts is, yes, we still have some challenges. There is a room for improvement, but today we are the solution for you. Because drones shouldn't just only fly, you need to fly smart. And that's actually what we are here to achieve. Thank you.
Values are changing right now, and it's okay. Make it higher speed. Increase the speed a bit. Okay, right now, motors. The RPM for each motor shows in the GUI, and all the motors are rotating. So that's the value for each RPM for each motor.
Okay, now because one motor is not working, so all the motors will stop and the parachute will launch, as we can see here.